Okay, Assalamu alaikum. The plan now in this video is to go through these exercises. I assume that you have already tried them yourself, and now I'm going to do it for you so you can check your answers. Okay, let's come to MATLAB, and you could, for example, try a new script. And let me just open both of them so I can see the question as well as MATLAB. Okay, so again, it's a script, so I would start with the three statement. Okay, now here we've been given a time equal to 0.35, and of course I would suppress it, and I need to evaluate those six equations. So this is basically a consecutive calculation. Okay, so number A, so this is a comment, so it won't be, that will be ignored by MATLAB at execution. So the first one is len, and we don't have len in MATLAB, so we have log. So we'll call this one A. So we have log 2 plus t to the power 2. So that's the first one. Okay. And then we have, well, I don't have to use A because I will use the letter here. So B equal to exponential, okay, exponential to the power, or exponential t multiplied by bracket, and inside that bracket we have 1 plus cosine bracket and close it to 3 multiplied by t. Okay. C is equal to the cosine t squared plus the sine t squared. Okay. D is equal to the a tan 1, and then we have E equal to the cosine t, sorry, the co t time, and finally F is equal to the sec t to the power 2 plus co t minus 1. Okay, and I can check all the answers here. I'm going to evaluate selection. So everything has been calculated. A, B, C, D, E, F. Okay, well, that's the first problem, which is very simple. Tamam. Next, he's asking us to create a vector. So this is regarding the second part where we have to create a vector and extract and delete some of the elements from that vector. So this is very straightforward. Now, just I want to tell you that the word vector could be a column vector or it could be a row vector. But the convention is whenever you read the word vectors, the assumption that it's a column vector. It's a column vector. كستاندرد it's become يعني دايما when we read the word vector alone we assume that it's a column vector, but it could be both column or row, depends on the context. فهني I could create a 2, 4, 6, 8, 10, and then I could transpose it. Okay, so this means transpose, and that will give you the matrix in a column vector notation. Okay, in a column vector notation. And if you remove the transpose, then you will get the row vector. And the rest are here, so you can do it yourself. So you just enter the data into a square bracket. Number three is asking you to plot this 4 functions. So I have 1, 2, 3, 4 functions. So this is ex to the power 2. This is ex to the power 2. I'm sorry. Well, we cannot do it in the word, but this is e to the power x square. Okay, that is the one here. So I have to plot, and he gave me the range of x. So x extends from 0 up to 4. Okay, including the 0 and the 4. So for problem number 3, so let's say this is number 3 here, and this problem number 2, and this was the problem number 1. Okay, so this one is comment. تعليق فقط. Okay, I might نفذ. This line is not executed. So now I have to define first my x. So my x would be 0, and it's up to me to choose the increment, and I choose it 0.1, and then I can plot the 4 function. Okay, so I have 4 functions. Let's call the first one y1. So y1 here is equal to x. And let's call the second one y2, and the y2 is equal to x to the power of 3. Now, very important things now I have to talk about it here. Now, if I put x equal to 3 here, okay, now let me go to MATLAB to just stress this point. Okay, so if I say x equal to, never says 0.1 up to, I can make it just a small one, 0 up to 5. Okay, so this is my x, 0, 1, 2, 3, 4, 5. And let's assume that I want to square أربع every element inside this vector. So if you go ahead and do this, you will get this error. You will get this error that inputs must be scalar and a square matrix. And to compute element-wise power, use the power dot exponent. Okay, dot exponent and a state. في الماتلاب شباب what we call it a dot operation, and that dot operation works with a multiplication, الضرب, and it works with the exponent, and it works with القسمة, the division. What does that mean? It means that whenever I want to do element-wise multiplication, I have to use dot multiplication. If I want to do element-wise exponent, the power, يعني أرفع every element inside the matrix أرفعها لpower, I use dot exponent. And if I want to divide every element by a number, I will use the dot division. We call this the dot operation. The dot operation. Okay. And I like to call it the element wise operation. لأنها تشتغل على every element alone. It works on every element of a vector on a matrix alone. So when I come to MATLAB here now, and أقول له this is my x, and I want to square every point, بقول له حط dot. Can you see? It's a dot exponent. Not only this. Yes, I have dots here. Now that's what he did. He squared every element 0, 0, 1, 1, 2, 4, 3, 9, 4, 16, 5, 25. We call this the dot operation. Okay. Next, if I want to divide every element here by, let's say, 3. Okay, every element here by 3. X, I don't tell him x over 3. I tell him x dot over 3. So this is like by saying, hey, go and divide every element of x by the number 3. And that's what we got. So the first element is 0. The second element is 1 over 3. This is 4 over 3. And this is, I'm sorry. It's x, not this one, okay? That's x. And this is the division. So this is 1 over 3, and this is 2 over 3, and this is 1. Yeah, it's 1. And then 4 over 3, and then 5 over 3. Okay? طيب, تمام. So come here back. Now I know that for me to divide, to raise every element of x to the power 3, I have to use the dot operation. The dot operation. y3. y3 is e to the power, so it's exponential x. And the last one, y4, is exponential x to the power 2, x to the power 2. Someone would say, oh, it's the same thing here, the same thing here. I have to put it like this. Okay, so these are the 4 functions, and he asked me to plot them. And the guy plot, right? He told me here to plot. And if I want to plot, there are 4 functions. So it looks like a multiple function. So I have to plot them in one plot. Now let's do this. So I have to plot them using hold on. Okay, that we just explained it in the previous video. So I'm going to plot for me x versus y1. And then I would tell him, hey, hold on. And على نفس الفigure. And plot for me نفس الشيء. Well, just copy and paste them. So this is number 2, number 3, and number 4. So if I run this, I will get the 4 plot على نفس الفigure. So let's try this. So just highlight this and evaluate selection. Sorry, I didn't. I have to evaluate everything here. Okay. So, well, you know what? Let's put them in a different file. عشان ما يأذيني. So let's have them here. So you can see clear all. So every time I just run everything, it would be easier. Okay, so now this is the figure. This is the figure. I have the 4 plot here. Why did you go? Where is the 4 plot? I can only see 1 here. Yeah, that's really a problem here. Actually, the 4 are there. The 4 are there, and you could see them if you go down here. Okay. Okay. Now, why I cannot see them? Why I cannot see them even though they are already here? They are already here. See, this is a yellow line here. So why I cannot see them? It's the order of magnitude. The order of magnitude of the 4 function. And if you know order of magnitude, okay, let's come to MATLAB. What does it mean, the order of magnitude? I have y1. Okay, oh god, is it row vector or a column? Yeah, it's a column. Okay. So I have y1. So the first one is y1. خلينا نحط الكولوم عشان نشوفهم بس. I just want to show you the value. The الأرقام مش كبر. Okay, and that will tell you why I cannot see them. Okay, look at the number here. النمبر هني لاحظوا هاي 0.1, 0.2, then 0.0. This is 1 point. الorder of magnitude يعني مقدار الرقم. Look at the مقدار الرقم. And then look here when I go down. لاحظ هاي 2.3 وهاي تقريبا 200. And look here when we go at 3.4 و 3.5. لاحظ هاي الأرقام أحد أي عشرات like 30s 40s, and look to this guy 10 to the power 5. So this is a very, very large number. This is a very, very large number. So it's like that when you put 3.4, you have this number will dominate. So I cannot see this guy alone. Okay, I will not be able to see this guy clearly because of the domination that happens by this large number. So واحد بيقول what can I do? Well, don't plot this. I رابع واحد, it has a very large order of magnitude, so he shouldn't be with this 3 functions. He shouldn't be with this 3 function. So what can I do? Well, I could have this 3 in one figure. So I will call this figure. Well, once you see figure in MATLAB, he will generate for you an empty figure. I'll show you. So when you come here, تقول له figure, he will open for you this figure. If you tell him another figure, he will put you for another figure. لاحظ I different than الأولي. So I have now two figure. You write another figure يفتح لك واحد ثاني. Okay, so now what I want to do, I will open a figure and I will plot this is 3, 1 or 2 or 3, and then I will open another figure and I will plot this one alone. Let's see what that will do for us. Okay, now look here. This is the first figure, figure 1, and this is the second figure. Now you can see that these three equations, اللي هو y1, y2, y3, I can see them. مساوي هذين الثلاثة كانوا مرعصين تحت. They've been this three equation or this three curves where it's squeezed here in this range, because see the maximum here is well 65, let's say. And look at the y-axis here, 10 to the power 6. So 76 is somewhere here. You cannot see it. It's in that region here. Okay, so that's why when you have three curves with a different order of magnitude, try to not to have them in the same figure. Do we have something like this in application, in chemical engineering application? Of course. For example, if I'm dealing with the molar fraction, the molar fraction is 0.1, 0.2, 0.5, right? And then let's assume that I want to plot the temperature as well. The temperature might be in Kelvin or Fahrenheit, okay? And if it's in Kelvin or Fahrenheit, you're talking about 400, 500. And imagine that I have also the pressure in the unit of Pascal. So I'm talking about 101,325. This is like a 6-digit there. Okay, so we do have in engineering different variable that has values or levels of a different order of magnitude at which you will end up with something like this. Okay, now you have, of course, to, once you need to plot, you don't forget to label the axis. So everyone has its X label, and all of them have X. So I can have it once. Okay, I can have it here. X label is X, and the Y label here, the Y label here is Y1. Okay, I can now just copy and paste this one here and here, make this one 2, make this one 3. Now, this is actually a wrong thing to do. I'll tell you why. Look here. If I do this, آخر شيء بيحط لي Y3 because this will be override the previous one every time. So the best thing to do is to write here just a function y. Okay, so I'll remove all this. I will write just y. So all of them are y. This is what I mean. Okay, so كلهم y. But then which one is which? How to tell him which one is which? Probably you would say the legend. The legend. So the legend is what will tell the reader which function is which. So y1, y2, y3. So all of them are y. Okay, all of them are y. But now I can see, okay, the blue is y1. The orange is y3, and so on. Or you could also state divide ولا ترى هاي كلهم, all of them are this. All of them are this, and then you have to use the legend. So the y-axis is y1 or y2 or y3, and you have to use the legend to know which is which. This is another way to do it. وما عندي مشكلة, of course, في الأخيرة because I have only one y4, so I have to label the axis and tell him that that is y4. Okay, so now I have two figure with the two with the 4 function. Of course, you can use them in a subplot as well. You can use them in a subplot. And there is something else, but I'm not going to go through it. You can explore it yourself. We have a function called plot yy. Plot yy. For example, let's assume that I want to plot the y4 against the y1. Okay, so let's start another figure. So we have a plot yy. Okay, plot yy معناتها في 2 y axes. It will have 2 y axes. one on the right and one on the left. فبقول له أنا on the left I want you to plot for me x and y1 and لاحظ comma I plus x and y4 because they have different order of magnitude. Let's see what he will give us here. Okay, see here. Here كده بتلاحظ على اليسار عندي ال y1 because it's up to 4. Okay, and I know that y4 has a very large order of magnitude, which is 10 to the power 6. Can you see? And he plotted on the right. So he separates the two curves, one on the left and one on the right, because they have a different order of magnitude. They have different order of magnitude. And then one would say, can I have the 3 plot on the left, since they are more or less have the same order of magnitude, and have the 4th function on the right? Well, you can try this yourself by going to the help and check the plot YY. Can I have more than 2 function, or it's only 2 function? Okay, you can try this yourself. So, but the answer for this question is this part. 2 figures, so they have different order of magnitude. So that's the answer. Tamam. So let's move. Plot the expression of the US population. Okay, where T is the data in year, and it goes from 1790 to 2000, and then he is asking you to predict at 220. Okay, so the data is this, and he's asking you to predict at 220. So this is like a consecutive calculation in addition to plotting. Okay, so let's do this. So in the same curve here, the same, I'll just try new M file. And I have to, again, it's a script, so I start with this. And then I need to plot this function. So P, capital P, as here, is 197.197.273.000 divided by 1 plus, okay, it's a bracket, 1 plus exponential, and inside the exponential, minus 0.0313 multiplied by bracket, open and close it, and then fill T minus 191.3.25. Okay, so that is my function. And of course, for me to be able to evaluate this function, I need to define my t, because it's a function of t. So t is equal to 1790 up to 2000. Now, if I keep it like this, he will use 1 as an increment. The default increment in MATLAB is 1. So 1790, 1791, 1792, and so on. Okay. Now, if I want to see what is the p-value. I want to see what are the p-values if I run this script. Do you think I'm going to get any problem if I just run it like this? Let's see. If I run this, I'm going to get a matrix error using the division. Well, the problem here is that I'm dividing this number by a vector. I'm dividing this number by a vector. Okay, let's do a simple example here so you can see. Let's assume I have x multiplied, okay, or different x, let's say 2, 3, 4, 5. This is my x. I want to divide, let's say, 10 over x. look, I'm getting the same error that I have just got. So what that means? That means this is a vector. So I cannot divide a scalar by a vector. So what I have to do is I have to use the dot operation, because the dot operation is like that. You are telling MATLAB to divide 10 over 2. Okay. So when I use the dot operation, so this is my x, 2, 3, 4, 5. So when I use 10 dot x, he's going to use 10 over 2, 10 over 3, 10 over 4, and 10 over 5. And that would be the new vector. So this is the element-wise operation. Every element put denominators to divide the 10. Okay? So that's what you have to do here. So I'm going to go at 10 now, 10 dot division, I'll get the answer. So that's solve the problem that we have here. Okay? So here I have to use the dot operation. Now if I run this, it will be okay. Where is the P? Well, you cannot see the P because I'm using the suppression. But I can just type P here and you'll see all the numbers are calculated. So now how to plot this? You just plot them with the plot command. So plot T versus P, right? And then grid on. And of course the X label is T and the Y label is P. Of course, you can use the unit, and then don't forget to give a title, which is P or T versus, again, it's a string. It has to be V versus P, and then you run this, and you will get the curve. T versus P. Perfect. Now, what he's asking for, he's asking to find what is the population at 2020. Now it's very simple. You go and substitute 2020 in this equation. Okay, now probably it's a good point to tell you how can I do this automatically as well. By let's discuss this later. The simplest thing to do is that you define T again here, 2020, and then you just evaluate the expression again. Now, do I need to use the division or remove it? Doesn't matter. Doesn't matter. Because this is a scalar, you can do both. Let's see. Let's remove it first and ask MATLAB to calculate for me the answer. Okay, so I'm coming here and tell MATLAB, yalla MATLAB, calculate for me the answer. So evaluate selection. Give me this number. What if I put the division? Well, he will also be able to calculate. And واحد بيقول لي, well, then it seems it doesn't matter, so I can use the dot all over the place. I would tell you no, be careful. I do have examples where you really have to know when to use the dot operation and when not to use it. Okay, so if you know that I don't need it, I don't need to use the dot operation, don't use it, because this is a scalar. This is a scalar here in this example. لكن هنا لا, it was vector. It was vector, and that necessitates the use of the dot division here. Okay, so that in this example. Can I have this point على الplot? For example, can I do this? Can I plot this point over the previous plot that I have it here? Yes, you can, but you have to use, okay, تقول له hold on. I have to tell him hold on. So you tell the MATLAB, once he plot this, hold on. And then when you come here, you can plot. This is a single point. This is a single point. One might say, you told us not to plot single point because You told us to plot a vectors against a vector from the previous video. Yes, but I already have this plotted. Point alone won't show, you will not be able to see it on a figure. Then it will just one point. But here, when you plot it over a curve, you will be able to see it. Okay. However, حتى لو أنا رسمت كذي, now here when I plot it in this way, okay, you won't be able to see this particular point here. I'll show you. Okay. Now, وين ال X, or where is the point that represents 2020? For that, I need to شوي control the marker size. I think it's the marker, not sure about that. And make this one something like 20. No. This is the marker size. No, it works, but it doesn't show me the plot. What I want to do is I want the point 20, 20, which is supposed to be somewhere here, but maybe I need to, let's see, X red. Yeah. Maybe I can show it because I didn't use the marker. Yes, that's what I want to show you. Okay, so that's the point X. لاحظ هاي just a single point. This is just a single point. This is not a curve. Okay, so when I say I want to plot a single point, it doesn't make sense. It doesn't make sense. So if I go right away without plotting, let's close the curve. يعني إذا أنت plot only single point, which is this one, this is what you get. It's just a point in the curve. And if I don't use a marker size, يعني إذا أنا قلت له this is 1. Look, if you go and plot this alone, you might see nothing. Okay, nothing. In a marker size, if it's like say 0.5, a very small number, and you واحد بيقول لي I don't get anything in the curve. This is the question I used to get to the exam. Okay, I'm not getting anything. I'm plotting and there is no error. Look, there is no error. I don't have error in the command window, but nothing show up. The first thing you have to do is you have to check the size. So you will find that the size is a scalar. So we don't use the plot for a single point بروحه. We use it when over to superimpose a plot that you already have. And that makes sense here. If I use, for example, this here, okay. So this is where the 2020 population. Okay, that ended this example. اللي بعده. Okay, here we have number 5 now. Here is very simple. You want you to plot this against this one. And then you have to use a proper label. So you have to create a vector for this and a vector for this, and then you plot them against each other. I think I'm not going to do this because this is straightforward. Okay, come here. For number 6, write a program to calculate. But I would say not write a program, just plot. I'll remove those sentences and I'll write plot. So plot vapor pressure. Plot the vapor pressure against the water according to Antoine equation. Oh, نفس الشيء. Test the program with a value of 2375. It's very similar to this one. So let's do this quickly. So I'm going to start a new script. I will start with this 3 line. Okay. And then we start equation here. So the equation here is telling me your P naught is equal to the exponential A minus B over bracket T plus C. Okay, so that's my equation. So for me to calculate this equation, I need A, which is equal to 18.3036. B is equal to 816.44, and then C is equal to minus 46.23. Okay, and of course I need a temperature range. Okay, now he gave me 3 to 3, so I'm going to take something around this. Probably I have to tell you here, plot the vapor pressures of water according to equation where T is any given Kelvin. Well, let me give you a range of temperature here so you can use it. So let's say the temperature goes from let's say 2 to 3.15 up to, let's add 500, like 800 to 3.15. Okay, so that's your range. That's your range from 2 to 3.15 up to 8 to 3.15. That's your temperature range. Let me save that. Okay, so أنا غيرت السؤال دي شوية. I changed the question a bit. I asked you to plot over this range. So this is my range here. So this is my range. So I'm going to come again to my code now, and I'll tell him, okay, I want the temperature here to be to be this one. So I tell him the increment is 0.1, so I can have a smooth curve. So that's my temperature. Any problem here? Well, واحد بيقول لي, okay, let's run and see if I get any issue. But some of you, I think, will be able to tell me that. Here. Some of you will tell me, we know that we are going to get this. Why? Because you have a range of temperature here and you forgot to use the dot. Okay? بالضبط نفس المثال اللي قبله. It's the same as the previous example. So I need the dot here. Okay? Now if I have the dot here and I run this, everything is okay. Did I calculate a range of pressure? Yes. There are many. Can I plot them now? Yes. So plot temperature versus P0. And of course, the label is temperature, and the Y label is the P0. What's the units? Let's some units. When the word, that's the word. Just have the unit. The temperature is Kelvin, and the pressure is the detail. That's the pressure. Didn't tell us the pressure, but let's assume that that's sorry, Gabo. So he didn't give me the pressure unit here, but I think it's a bar. I think it's bar. Okay, well, let's also use any unit here. So let's assume that it's atmospheric. And the temperature, of course, he told us that it's a Kelvin. Okay. And of course, the title is the temperature versus pressure, 0, vapor pressure. So I have everything here. So when I go ahead and evaluate this, I'm going to get the curve. And then he told us to calculate the beta at certain pressure. He asked us to calculate the vapor pressure at certain temperature. And then at that particular temperature, which is 232.15, all what I have to do is just, I can reevaluate the function. Okay, should I use the dot or not? We have discussed this earlier. So that is the temperature, or the vapor pressure at that particular temperature. Okay, so that's end exercises اللي موجودة in the notes. Okay, I would highly recommend that you get some of any more extra problem from your 111 book. You will get more problem where you need to plot so you can have more exercises. Also, I'm going to post for you, it's an assignment, okay, that you can do it there are many problems that you can do it yourself to test yourself more on how to use the plotting function. Okay, thank you very much, and I'm going to stop here.